Welcome to Test Artifacts Mastery, a module focusing on building professional QA documentation for client projects as part of the Manual QA training program. Our session objectives include understanding the test artifact hierarchy, creating professional test strategy and test plan documents, and designing high-quality test scenarios and test cases with traceability. We will also cover applying AI tools to accelerate creation without losing critical thinking, delivering client-ready documentation, and evaluating artifact quality using checklists. Test artifacts are critical for accountability, communication, and traceability. They prove what was tested and align stakeholders on scope and risks. They also ensure every requirement is mapped to a test case, tracking coverage gaps. This diagram illustrates the hierarchy of test artifacts, starting with the high-level test strategy, progressing to the test plan, test scenarios, test cases, and finally the supporting artifacts like bug reports and test summaries. Part 1 focuses on the test strategy document, which serves as the strategic blueprint for your QA approach. A test strategy is a high-level document defining the overall testing approach for an organization or a large program. It is created by a QA lead or test architect before project testing begins and is reviewed by stakeholders. Key components of the test strategy include defining the scope and objectives, the testing approach and types, the environment and tools to be used, and a robust risk assessment and mitigation plan. Further components cover the schedule and milestones, roles and responsibilities, metrics and reporting mechanisms, and clear entry and exit criteria for testing phases. When crafting your test strategy, remember that sections like the introduction should be concise. Use tables for scope clarity and justify every testing type chosen. Ensure key elements like the risk register and schedule are properly detailed and aligned. AI tools can assist with strategy creation by generating initial outlines, drafting risk entries, and creating metric definitions. However, avoid submitting generic AI output. Always customize and validate for project-specific accuracy. Part 2 dives into the test plan document, which acts as your project's tactical testing roadmap. The key difference is scope. The test strategy is organization-wide and strategic, focusing on the what and why. The test plan is project-specific and tactical, detailing the how and when of testing resources and schedules. The test plan, often following the IEE 829 standard, includes sections from identification and versioning to approvals. These sections cover everything from defining test items and the testing approach to managing defects and specifying deliverables. Effective entry criteria ensure testing starts only when requirements, environments, builds, and test cases are ready. Exit criteria define when testing stops, typically requiring 100% execution, P1/P2 defect resolution, and stakeholder sign-off. Several techniques exist for test effort estimation. The work breakdown structure is the most common, breaking tasks into estimable hours. Other methods include test point analysis, use case points, and leveraging historical data. Now we move to Part 3, Test Scenarios. This section is about translating high-level requirements into clear, testable scenarios. A test scenario is a high-level, one-line statement describing what functionality to validate. It serves as a foundation, generating multiple detailed test cases. For instance, testing a login module involves scenarios for valid login, invalid passwords, account lockout, and browser compatibility. Several techniques guide scenario writing. Requirement-based techniques address what can go right and wrong. User story mapping covers happy paths and error paths. Equivalence partitioning groups valid and invalid inputs, while state transition and exploratory techniques cover workflow states and risky areas, respectively. The Requirements Traceability Matrix, or RTM, is critical. It proves every requirement has test coverage, shows verification progress to stakeholders, enables impact analysis during changes, and is essential for compliance audits like HIPAA and GDPR. Part 4 focuses on test cases, which are the heart of QA execution, detailed, repeatable, and traceable steps derived from your scenarios. The anatomy of a test case is detailed and highly structured. It includes the ID, title, priority, prerequisite setup, detailed steps, test data, and a measurable expected result. The outcome of the execution is then logged as a status and includes comments and attachments. Good test steps are specific, measurable, and repeatable. Avoid vague language like, check it works. Instead, use precise actions, exact test data, and observable expected results. A golden rule is one action per step. You will write several types of test cases. These include positive tests for success, negative tests for graceful failures, boundary tests for extreme valid/invalid values, edge cases for unusual but possible situations, and integration and regression tests. Key test case design techniques include equivalence partitioning, where you select one value from each input class, boundary value analysis, which focuses on limits, decision tables for complex multi-condition features, and state transition testing for verifying system workflow states. Effective test data management uses static data, like standard accounts, dynamic data such as unique emails generated on the fly, and masked or synthetic data to handle sensitive information for compliance. Part 5 looks at AI tools and templates, demonstrating how to accelerate artifact creation with modern resources. The AI-powered workflow starts with gathering context, followed by prompting the AI with specific project details. You must then review and customize the output before finalizing and storing the artifact in your project management tool. Remember the 70-30th rule. AI provides 70% of the draft, but the remaining 30% is your crucial contribution. This 30% includes adding project-specific context, domain logic, and critical compliance requirements, which transforms generic output into a professional artifact. Establishing clear template standards and naming conventions, such as ts_project_name_version, ensures consistency and easy identification. Store documents like test strategies in Confluence and test cases and bugs in systems like Jira. Finally, in Part 6, we apply all these concepts to a real-world application, showing how these artifacts come together on a client project. Our client project is an e-commerce platform for Retail Max, launching a new checkout system. It is a 3-month project covering the shopping cart, checkout flow, payment gateway, and order confirmation. We are a QA team of 3, using Jira and adhering to PCI DSS and GDPR compliance. Here is a quick checklist for reviewing your artifacts. Use it to ensure completeness, accuracy, and traceability. Always confirm that your test data is valid, requirements are correctly interpreted, and everything is linked back to the original user stories. Avoid common mistakes like using generic AI output. Always customize with real project details. Replace vague expected results with measurable outcomes, like specific calculated totals. Ensure you include negative and boundary test cases, and maintain your RTM from day 1. This concludes our instructional segment. We now move into the hands-on assignments, where you can apply these concepts to practical exercises. Remember these key takeaways. Test artifacts are your proof of quality and follow a clear hierarchy. I can accelerate drafting, but your domain expertise is essential. Traceability is non-negotiable, and great test cases are specific and executable. Thank you for completing this module on Test Artifacts Mastery. Now go build artifacts that truly impress clients.